Hi, how's it going, everyone? Welcome to Kunlun's mini lecture. In this lecture, we will cover a very basic or fundamental CS architecture principle that is the heap memory allocation. Before we delve into that, I want to begin our discussion by introducing a very important definition. That is the definition of stack versus heap. So for those who are unfamiliar with this definition, uh, a stack is basically a special region in your computer's memory that stores temporary variables created by each of your functions. So what I mean by that is that every time a function of your program declares a new variable, it is pushed onto the stack. And then every time a function exits, all of the variables pushed onto the stacks are freed. That is to say, they are deleted from the stack. So as you can see, a stack looks pretty nicely ordered, and it is growing from a relatively low memory number to a relatively high memory number. And in contrast, heap is a region of your computer's memory that is not managed automatically for you. That is to say, it is not as tightly managed by the CPU as the stack. So it is more of a free-floating region of your computer's memory, and it is usually much larger than the stack memory. So to allocate memory onto the heap, uh, you must use either malloc function or the calloc function. So malloc basically stands for memory allocation. So the key difference between a malloc function and a calloc function is that calloc function automatically zeroes out all of the memory you've just created for you. And so once you have successfully allocated memory onto the heap, you're responsible for using the free function to deallocate the memory if you don't need it anymore. So now I'm going to talk about how we can actually using these functions to allocate heap memory. So before I talk about how to actually use functions to do that, I want to quickly introduce several nomenclatures and rules that's going to be very important when you're doing heap memory allocation. So this is a standard view of a heap segment, and each of the block in this heap segment is going to be a single byte, and four bytes is going to form a word, and 2 words is going to form a double word. So the rule of heap allocation is that it's going to be using a principle called double word alignment. So double word alignment basically requires that the block size must be a multiple of 8, which means that every single memory block should be a multiple of 8. For example, 8, 16, 24, etc. And your payload address should also be a multiple of 8. That means once you've allocated memory, the address of your pointer should be a multiple of 8. So after all that, we're going to talk about how to actually use the functions to allocate memory to the heap. So over here we're not going to be talking about how to use calloc, but instead we're going to be talking about how to use the malloc functions to allocate memory. So basically, we're in your program we're going to be using something that looks very similar to this. So this means that we're trying to allocate 2 integers to your heap segments. So 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 the integer in C language takes up 4 bytes. So that's going to give us 2 times 4 equals to 8 bytes. Since 8 itself is a multiple of 8, then we don't need any padding. So what I'm gonna do is just like +0, which means we don't need to add any padding. So we're gonna be allocating 8 byte. So if not otherwise mentioned, we're always starting from the very beginning or the lowest number of the address when you're allocating memory to the heap. So what I'm gonna do is that so this one is gonna be your P1. P1, that's gonna be your pointer. So it's gonna be point to this location, and it takes up 8 bytes. And for the second case, we're basically allocating 3 chars to the heap. So each char in C sequence is just 1 byte. So we're doing 3 plus 1, which is going to give us 3 bytes. However, 3 is not a multiple of 8. So we want each block to be at least 8 bytes. So we need 5 additional bytes of paddings, so which is going to give us a total of 8 bytes. So what I'm going to do is that so for the paddings, I'm going to represent it as a circle. So basically we have 3 actual memory slots and we have 5 padding slots. So over here what I'm going to do is so that's going to be 3 actual memory slot, and the rest of the block is going to be your padding. And the pointer should be over here. So basically, the pointer finds that at this particular address, the space is basically empty, so it can just like take up this spot and occupy it with the memory. So for the next allocation, we're allocating 4 integers into the heap. So 4 integers, each integer is going to be 4 byte, and that's going to give us 16. So since 16 is a multiple of 8, we're not going to add any padding to that. So the pointer finds that at location 10, there's going to be a free spot, so it's going to take up that spot, and it's going to be allocating 16 bytes of memory to that. Okay, so that's P3. And P4 is trying to allocate 5 integers into the heap. So 5 times 4 gives us 20. However, 20 is not really a multiple of 8. So the closest multiple of 8 should be 24. So we need to add 4 additional padding, so which is going to give us 24 bytes. So the pointer finds that at location 20 there is a free spot, and so it's going to basically take up that spot and allocate the memory. So notice that we should really take 3. So these 20 bytes should be our actual memory. However, the last 4 bytes should be our padding here. Just be very careful about it. And okay, so we've talked about how to use the malloc to allocate memory. Now we're going to talk about how to use the free function. So basically what it does is it's basically wipe out your memory over here. So it's basically going to empty your memory at this particular spot, and so that's what this free P1 does. So a very good practice for a beginner programmer is that we're going to assign P1 with null. So that means we're basically just going to take this P1 away and throw it into the trash. So this means that we have completely freed this particular location, so we can reuse this location again and again. So that's the step 5 and step 6. So we're freeing P3. So P3 over here takes up 16 bytes. So what we can do is we're gonna free P3. We're just gonna uh, empty this location here, and we're gonna do P3 equals to null. We're just gonna basically delete this pointer. And finally, so we're doing another allocation. So we're basically allocating 6 integer values to our heap. So 6 times 4 equals to 24. So basically we're trying to allocate 24 bytes to our current to our segment of heap over here. However, so if you examine this very closely, so we cannot find any consecutive segment of heap that is 24 bytes long. So that basically tells us that the allocation basically failed. So over here it's going to be allocation fails because it is not be able to find a consecutive segment that contains 24 bytes. And once the allocation fails, this malloc function is going to return a null. So when we get a null from our malloc function, we can know that this particular memory allocation actually failed. So that's about the end of this mini lecture. So I hope this lecture makes heap memory allocation much clearer to you, and I hope you enjoy this as well. Thank you very much.